All right, let's dive into one of the most powerful and honestly most important ideas in all of technology, supervised learning. It is the engine running behind the scenes of so much of our digital world, and today we're going to pull back the curtain and see exactly how it all works. You know that feeling, right? You're on a website, you plug in a few details about a house, and bam, it spits out a price almost instantly. It feels a little bit like magic. Well, it's not. It's actually a machine that's been taught to see patterns, and we're about to find out exactly how it learned to do that. So here's our game plan. First, we'll get into what it means to learn from answers that are already known. Then, we'll unpack the simple A to B formula that is at the heart of everything. We'll look at the two big ways it makes predictions, see it in action in the real world, and then wrap it all up with the final takeaway. Ready? Let's go. Okay, so what is supervised learning, really? When you strip everything else away, it comes down to a really simple but really powerful idea. A machine learns by studying examples where we've already given it all the right answers. Now, the official definition uses the term labeled data. That sounds super technical, right? But all it really means is that the computer gets a whole bunch of questions, and crucially, it gets the correct answers to go with them. You can think of the supervisor here as basically being the answer key. And this is really where it all just clicks into place. Think of the machine as a student. You're not just handing it a textbook and wishing it good luck. No, you're giving it a workbook that's jam-packed with solved problems. It just studies these examples over and over and over until it starts to see the underlying patterns for itself. Now let's peek under the hood at the core logic that makes this whole learning process tick. You'll be surprised to find out it all boils down to a beautifully simple formula. This is it. It all comes down to this. Input A leads to output B. The entire goal is to train the machine so well that whenever it sees a brand new, totally unfamiliar A, it can look at it and confidently predict what the correct B is going to be. So let's break that down just a little bit more. A is your input. That's the question, the set of facts, the study material you provide. And B is the output. That's the correct answer, the solution you want the machine to learn. The machine's entire job is to just figure out the hidden connection between the two. And here's where this gets really practical. For an email, the input A is all the text, the sender, maybe some keywords. And the output B, it's simple. Is it spam or not spam? For a house, A is things like square footage and location, and B is the price. See the pattern here? You give it the question, and it learns how to predict the answer. Okay, so just like back in school, our machine student isn't just taking one kind of test. There are actually two main ways that can be tested, and it all depends on the kind of answer we're looking for. Those two types of tests are called classification and regression. Classification is all about predicting categories, things that fit into neat little boxes. Is this email spam or not spam? Did the student pass or fail? On the other hand, you've got regression, and that's all about predicting a specific number on a sliding scale, like the exact price of a house or what the temperature will be tomorrow. Honestly, this is probably the best way to remember the difference. Classification is just like a multiple choice question. You have to pick one answer from a predefined list. But regression, that's more like a fill in the blank, where the blank needs a very specific number. All right, so our machine student has its study guide, it knows what kind of test it's taking, so now what? Let's see how this whole studying process actually happens and how it gets applied out there in the real world. The process itself is actually super logical. First, you gather your study guide. That's all the labeled data. Then, and this is clever, you split it. Most of it is used for practice, but you hold back a small chunk for a final practice exam. The model then trains on that big practice set, studying all the patterns. Next, you evaluate how well it does on that test data it's never seen before. And once it's getting a good grade on its practice runs, well, it's finally ready for the real world, to take the final exam on brand new data. So where does all this theory actually start to make a real difference? Well, one of the most critical, life-changing applications is in medical diagnosis. So in this case, the input A is all of a patient's symptoms, their lab results, their medical history. The model, which has already studied thousands of past cases with known outcomes, predicts the output B, a potential disease. Now, this doesn't replace doctors, of course not, but it's an absolutely incredible tool to help them make faster, more accurate, and more informed decisions. The impact is huge. Now let's talk about an application you probably use every single day, maybe without even thinking twice about it. Image recognition. For this one, the input A is really just the raw data of all the pixels in a picture. But the output B is what makes it so amazing. It's a label for that image, like cat or car, or maybe even a specific person's name. This is the core technology that powers everything from your phone unlocking with your face to a self-driving car being able to identify a stop sign. Okay, let's bring this all home. Time to zoom out and lock in the final takeaways from all of this. What's the report card on supervised learning? Here's what you really need to remember. At its core, supervised learning is all about learning from examples where you already know the answers. It works by mapping an input, A, to an output, B. It can predict either distinct categories, like a multiple choice test, or specific numbers, like a fill in the blank. The entire process is just about studying the past to be able to predict the future. Simple as that. And that really brings us to the most important point. Supervised learning teaches machines by example, in exactly the same way that good teaching teaches students. But that raises a really crucial question, doesn't it? If these systems only learn from the examples that we give them, then the quality, the fairness, and the accuracy of those examples matter more than anything else. What we choose to teach them will ultimately define everything that they become.